Okay, so here I'm going to take you through cross sections of 3D objects. You're going to have to do these problems, and I have to tell you, I sometimes get these wrong. You might get these wrong for a little bit, but I'm not perfect at these, so let's just see. I'll make sure I get 5 in a row right, though. Here we go. Which object shown on the right could be sliced to create pentagon cross sections? So a pentagon, that is a polygon, so no curved sides, right? If it's a polygon, it cannot have a curved side. Pentagon means it has to have 5 sides. Well, I can't create, the only thing, if I went straight down the center here of the cone, then I could have that be the vertex. If it has the same, the two-dimensional object have the same vertex as the cone, well then I would have 3 sides only. So the best I can do with a cone that's a polygon is a triangle, so it's not that. In a circle, there's no vertices here. Every side is rounded, so I can't do that here. Here I've got rounded sides. I could make a rectangle, right? If I cut parallel to the diameter, I could create a rectangle here, but not 5 sides. I need a pentagon that's 5 sides. So here I have a cube, and what's really nice is when you have a when you have a prism, you can count the number of faces of the prism and figure that that's the total maximum number of sides of your polygon that you can create. So this has 1, 2, 3 side faces showing, and there's 3 faces that are hidden. Just like a dice goes 1, 2, 3, 4, 5, 6. Those are the numbers that show up on a die if you were to throw it. So I could get up to 5. I could get up to 6. So I could get a cut of 5 here. I could make a pentagon. Here I have 1, 2, 3 sides on the 3 faces with the triangular prism, plus the top and the bottom. That's the bases. So that's 5 total sides I could make with a polygon that I slice through. So that one could be. And here I have a pyramid which has 5 faces as well. So potentially I could get 5 sides out of that. So those are my answers. I'm thinking about looking very closely at these. Okay, which of the objects shown could be sliced to create trapezoid cross sections? So this would be, again, a trapezoid is a quadrilateral polygon, so no rounded edges. So we're going to eliminate the cone and the sphere right away. So now the question is, can I get a trapezoid out of a cube? Well, the key with the trapezoid is that the sides can only have 2 sides that are parallel. Unfortunately, when I take a planar slice out of a cube, the way it approaches it, it's going to create parallel sides no matter what, because this has, for sure parallel sides in any angle that I take at it. So I cannot get a trapezoid out of a cube, I don't believe. Prism, I should be able to get a trapezoid because I could, angle it to where it comes out. I believe I could. I'm going to put yes on this one. It's hard for me to describe that, but I see myself coming through here, and this face, the cut in this face, is not going to be parallel to the way that it cuts through the other face on the other side, because that's angled funny. It's angled at a different angle. So I believe I can get a trapezoid out of that. And I also, because of the angle, see how it tilts in? I think that's a key for a trapezoid, is that when you're cutting here, all the faces are opposite each other, right? And they're all right angles in every direction. Here I have something that's not raised at a right angle, so everything is not going to be parallel. So I'd say these two. And I'm wrong. I guess I can get it out of the cube too. Just goes to show you. I have a hard time seeing that, but I guess it just depends on the angle at which I cut through it. And I just not that good at it, okay? All right, 2-dimensional cross sections we could get by slicing a cube. I have a rectangle. I know I can get I can get a rectangle. I could get a triangle, right, if I cut it at a corner. And that's an equilateral triangle. I could cut it such that I do believe I could get a scalene triangle too. We just found out I could get a trapezoid. I'm not going to get a circle, but I think I can get an isosceles triangle. So I should be good there. We'll check our answer. Good. All right. A rectangular cross section that is not a square. Well, a rectangular cross section. So if I cut this guy diagonal, the length of my diagonal is going to be longer than the length of my side here. So I can definitely get a rectangle out of a cube. Out of a cylinder, yes, I can cut this. As long as my slice comes down parallel to the diameter, then I am going to get a rectangle out of my cylinder. Sphere, no. And here, no. Can I get a rectangle here? Sure. If I sliced like the top off, cut off that top, but the bottom face would be, you know, length here, width there, different length and width, so I could definitely get it there. Alright, can I do it with a right pyramid square? Well, I'd cut it down at an angle, and that way my length this way would be longer than my width that way. But then, my opposite side, would it be 90 degrees? So I'd have a long side here and a short side there. I don't believe those angles would be 90 degrees. Okay, I just can't see it. So I'm going to leave it out and probably get it. Oh, I got it right. There it is. Yeah, I think in order to get a 90-degree angle, I'd have to be plane in my cut here, right? And if I did that, I'm going to get a square. If I am parallel to the base in my cut, I'm going to get a square. If I go non-parallel, I'm going to end up with one side wider than the other, and rectangles don't have that. So that was my thinking there. Okay, I don't have 5 in a row yet. Let's hope I can get 5 in a row. Here we go. Two-dimensional cross-sections we can get by slicing a cube. Okay, I know I can get a quadrilateral. Let's just cut it right down the middle. I get 4 sides. A hexagon, well, I have 6 faces, so I could get 6 sides. A triangle, yes. A pentagon, 5 sides, but I cannot get 7 sides if I only have 6 faces. So I'm not going to get a heptagon. Well, that's good. All right. Slicing the cylinder. Can I get a pentagon? No. The best I can do with a polygon, or the most I can get, is a rectangle, right? If I cut it parallel to the diameter, I get a rectangle. So I get that. I can get a circle. I just have to cut it parallel to the base, and I'm going to get a circle. An ellipse, which is a non-circular but round object. So if I cut it at an angle, it'll have like a long side and then come back up around. So I can get an ellipse there. Isosceles triangle. Well, I need to have a vertex, so I could cut it right here. And I could get one face here, but the other side, I'd get another side here if I cut it. So I'd say no on the triangle and no on the square unless the diameter was the same as the height, which it clearly appears not to be. So I'm going to just go with those 3. Okay, here we go. Which ones could be sliced to create a circular cross section? Well, if I cut this parallel to the base, that's a circle, then that cone is going to give me a circle. A sphere, that's about all you can cut off a circle. In fact, I think a sphere is the only shape you can cut off a sphere is a circle. I might be wrong about that. Cylinder, if I'm parallel to the base, I'll get a circle. I cannot get a circle out of any of those, so I should be good. And now, there we go. I am practiced on that one. So that's how you do them. Go ahead and get that one done.